Afternoon. I'll start with a little bit of description of what was done in the last class. So today we are going to start with non-persistent and persistent HTTP connections. Okay. So in the last class, if you remember, we had seen that HTTP connections are categorized into two types: non-persistent and persistent HTTP, depending upon when the connection is getting closed with the server. Okay, so what we saw that in the non-persistent HTTP, the TCP connection is opened before the request is the sender requests for the object. So the TCP connection is opened between the client and the server. Once that connection is established, after that request is sent, and once an object is received at the receiver's end, at the sender's end, sorry, once once the requested object is received at the sender's end, after that the connection is closed. Okay. So in that case, what would happen is if you have multiple objects to download, in that case you would require multiple connections. Okay. So that means for if you have like some web page which is having a large number of objects or n objects, so therefore you will have to open your connections at least n plus 1 times, right? Because first one would be just to download the HTML file along with the links to the n objects that you have, right? So the persistent HTTP is just the opposite of it. That means the connection will be closed after everything related to the particular request is downloaded or is basically transferred from the server to the sender. So we had seen this example in the last class, so I'll just quickly go through it once more. So as we know that the URL will consist of the host name and the path name. Okay. So this part is the host name, this part is the path. Now, what does this contain? This page contains text and references to 10 JPEG images. Okay, so this HTML page basically consists of some text and some references to 10 JPEG images. So this is what is happening here, that the client initiates the TCP connection to the HTTP server um, of for this particular URL. Okay. So this HTTP server is requested for connection, and because it's HTTP, therefore we will use port 80, right? Then once this request is received at the server side, the server will receive this, of course, it will receive this request at port 80 because the connection will happen at the same port number, right? So at port 80, the connection, the server will actually receive the request. Once it accepts the connection, that okay, I am accepting a connection from a particular client, and then it will send a notification to the client that I have accepted your connection. If you have any request, then send me the request. Okay, so that's what is received at here at step 2 from the server. So once the client receives this notification, it sends the actual request message to the server side. Okay. Now, what does this request message have? This request message will actually contain the information of what the client is actually asking for. So here the client basically wants to access this particular page, right? So this HTTP request message will indicate that the client wants the object this some department slash home dot index, and of course it has anyways contacted the server for this website, that is someschool.edu. So within that server it wants to access this object. So this is the content of the request message. Now this request message will be received by the server side, right? So once this message is received by the server side, then the server will respond with the content. Okay. So now, what is the content that the server side gives? Okay. The server side will actually send out that, the message that will contain the HTML file that contains links to these 10 JPEG images. Okay, so we knew that in the beginning we started with this, that this URL that we are looking for, it contains HTML text and it has reference to 10 JPEG images. So the images, the objects will not be obtained here, only the references. That means, you will get the HTML file and you will see that, okay, there is link for 10 JPEG images. Now we have to again start a connection to get the 10 JPEG images. Why? Because the moment the server sends a response. So see here, at step 3, the moment the server will send a response, before it, the next step that the server will do is that it will stop the connection here. Okay, so that is why it is the step 4. So it stops, it sends the response message, the server sends the response message, and consequently it will close the TCP connection. Okay, so that is why what will happen is, once this is received, once the response message is received at the client side, of course there is no more connection is there. Okay, connection has already been closed. So again, for the referenced objects, you have to start the connection again. So you have to repeat step 1 to 5 for all the 10 objects. Okay. So this is basically a cumbersome process, increases the amount of time for which time required to get requested object from the server side. Okay. So how much time is required? That is what we are going to calculate with the help of the metric known as response time. Okay. So that means, what is response time? If you basically raise a request or send a query to a particular server side, what is the time taken to get the response? Okay. So that is known as the response time, right? So to measure this, we use the terminology called as RTT, or round trip time. Okay, so RTT stands for round trip time. What is RTT? So the definition is given here. It is the time for a small packet to travel from client to server and then back. Okay, so that's what is given here. If you can follow the mouse. So what is an RTT? From the client side, a packet is being sent to travel from the client to the server, and then the response that comes back here. Okay, that amount of time until the client gets the response, that is known as a round trip time, or RTT. Okay. So here, if you see this figure, this is given for a non-persistent HTTP. Okay, so what would be the response time for a non-persistent HTTP? So now what we know is that in non-persistent HTTP, anyways in HTTP, TCP is the underlying transport layer protocol. So therefore, what you will do first, to get any kind of response or to even send a request, first thing is the connection needs to be initiated. So that's what is happening here. The connection is initiated, and then once this connection request goes to the server responds with an accepting the connection um, response. So it sends out the response. Once the client side gets the confirmation that the server has accepted the connection request, then it sends the request file. Okay, so as you can see here, here is the time stamp at which the request file is being sent from the client side. Okay, So the request file is now transferred from the client to the server. Once it reaches the server, then the server will respond with the requested file. Okay. Now, what do we know? When we are sending a particular file, okay, so we will be sending it as some small packets, right? But whatever the size of the data that you are sending, okay, you will have to consider the transmission delay for that. So here too, you will have to consider the transmission delay of the data that you are sending. So that is being considered here. Okay. So the first response will get, so the first time that you get a response from the server side here at the second step, then you consider that, okay, this is the RTT. And then of course you will have the time to transmit the entire file from the server side to the client side. So that is the transmission time for the for receiving the file. Okay. So as you can see here, per object response time for HTTP is first 1 RTT to initiate the TCP connection, 1 RTT for HTTP request, and first few bytes of HTTP response to return, and then the object of file transmission time. Okay, so this is how the response time for non-persistent HTTP is given. Twice of RTT plus your file transmission time. Okay. So we have done up to non-persistent HTTP. Now we'll go to persistent HTTP. Please remember we are currently studying HTTP version 1.1. Okay. So there are several others that we will look at also. So let's see the version 1.1 itself. So what do we know about non-persistent HTTP? That because it requires, to have TCP connection being established first, and then once the transmission of data happens, the server closes its connection. Okay, so per object you will require at least 2 RTTs, right? So 2 RTTs you require. Then what is it? So for, of course, for each object you will have to establish a TCP connection, which is an overhead for the OS. And in order to reduce the time to access all the objects from the server side, sometimes browsers open multiple parallel TCP connections, okay, in order to fetch the referenced objects faster. So these are some issues of non-persistent HTTP connection. Now, see, we are getting a lot of delay and a lot of complexities are also arising. So in order to overcome that, have this, we have this persistent HTTP, which is just the opposite of what non-persistent HTTP does. So what are its properties? One is that the server will leave the connection open after sending a response. Okay, so that means once it sends a response, it will keep the connection open for the other objects to be transferred, right? So what will happen that if the client side has other requests to be made, then it can make all the requests, and it will, once it receives a referenced object, because subsequently it will send the next request that it wants to send to the server side. Okay, so within 1 RTT you have, that TCP connection is done, and then next, first RTT you have the TCP connection, and then you can, in the next time instance itself, um, or sorry, not the time instance, in the next try itself, you can get all the objects that you are referring to. Okay, so that means your response time for getting a particular requested object from the server side becomes almost half of what was there in the non-persistent HTTP's case. Okay, so is persistent HTTP all the way better than non-persistent HTTP? Can we have an answer to this question? So my question is that is persistent HTTP all the way better than non-persistent HTTP?
Ma'am, like if it is a single static HTML page, then it doesn't have any references, so non-persistent will also work fine. But when we think about a larger picture, and the amortized time will be large if we have non-persistent, so persistent is like optimizing the entire thing, but it is not necessary that it is always required.
Okay. Uh, any other answers?
Ma'am, the server's resources will be like if there is a persistent connection between the client and server, the server's resources will be allocated to the server. So it usually it's good for multiple objects, but this will be a bit like there will be a overhead on the server.
When you say resources will be allocated, what resource will be allocated?
Like there is a persistent connection, so there needs to be a port or like for the client to be assigned so that there can be a communication directly without sending a request like request connection between the server and client. So for the so I mean that the server will be like giving a few resources to the particular client.
Okay, and any other answer? Acha, if I keep the server open, it keeps hanging, right? That when the client side will actually stop the connection, until then the server simply remains open. Now, if the client side somehow gets disconnected due to some kind of network issues and all that, before informing the server that it has received every object that it wanted, the server will still remain open. No? That connection will be a loose connection that will remain open. Is this clear? This what I said?
Yes, ma'am.
Okay, fine. So in that case, that is a disadvantage that you will get. Okay, in case of a persistent HTTP connection.
Ma'am,
Yes.
the client can send messages at regular interval, letting the server know that it's still interested in the resources from server. And if the server doesn't receive a message for some interval, it may disconnect the client.
Yeah, that's the solution you are talking about, right?
Yeah.
Solution to this problem. Yes. So solution to this problem are there, but I'm saying this is a problem that can happen in case of persistent HTTP. Now it will depend as to how much time will you wait, will your server wait, right? Because it may happen that your network is a very busy network. So in that case, you might have to wait for a longer duration. Or if it is not a busy network, then you wait for a smaller duration. So how long will you wait so that you actually can gauge that okay, maybe there is some issue with the client side, and then you stop the connection or close the connection basically. So that's again a calculation, and it's a very it's a hard estimation to make. Okay. But anyways, this is actually a kind of solution that is used in networks to actually find out as to whether the client is still on or not, whether the connection should still be kept or not. Okay, so we will see this kind of solutions also in this course. Um, okay, now let's get to the next part, that we are talking about messages being sent from the client side to the server side, okay, and vice versa. So there are two types of messages that are basically exchanged. One is request message and response message. This is for HTTP. Okay, so you have HTTP request message and HTTP response message. The messages are in ASCII format. Okay, so how does it look like? Looks something like this. Okay, this line get slash index.html http slash 1.1 carriage return and line feed character. Okay, so what is this get? The get is it can be either, it is a command. Okay, it is known as a request line command. What it does we will see in the next slides, but it can be either a get or a post or a head command followed by this path that you want, your HTTP version, and the syntax is that every line is ended with a carriage return character and a line feed character. Okay. Now there are several other parts to this header. Okay, in the request message, this is basically what the header consists of. So first is the request line. The next part is a set of header lines which will have a lot of information about the type of message that the type of data that the client is actually asking for and some properties of the client itself. So what are these? So first is, this is the host name. Okay, so host name is this www.net.cs.umas, and please note that every line ends with carriage return and line feed. Okay, then the user agent. Okay, user agent is, suppose you are using your browser to, of course, when you are looking at a particular website, you are trying to open it, you would be opening it from your browser. So this user agent is basically containing information about the browser version that you are using. Okay, so this is the browser version and um, the information about your browser. Okay, so next is the accept. What does this accept say? The That means the browser version that you are having in your system, it is going to accept these uh, these things, text or HTML. So whatever data you are asking for from the server side, your browser can accept that in this format, either in text or HTML or application slash XHTML plus XML format. Okay. What language can it accept in these? This is the language, English US or English basic UK. And then what is the encoding? Okay, what is the encoding with which the data that you have asked for from the server side, what is the way in which you are going to accept, what is the encoding? So that is gzip or deflate. And connection, keep it alive. Okay, so connection keep alive, and then carriage return and line feed character in the end. So this is how your request message will look like. Okay, so these are the header. So this is what will be there in the header. Okay, see, this is a general format of what your HTTP request message looks like. Okay, so method, see, look here, all these things that have been written here, this is the way in which it can be. This is just a format in which it is written. So this is the get space URL space version carriage return line feed. Then your header field name, then space, then value carriage return line feed again. So you have the request line, you have the header lines, and then you have the body of the message that you want to send to the server side. Okay, so up to this part, request line and header line, this is what it will look like. Okay, depending upon what is the kind of command that you are sending, okay, to the server side. All right. So as I was talking about, so there are several request line commands, okay, that you can send to the server side. So here are some of them. So one is the post method, okay. So post method means that it includes some form of input that you are sending to the server from the client side, okay. So suppose you in your website that you have opened, there is a field to input some data, all right. So that can be sent via the post method, all right. Whereas if you want some data from the server side itself, then you can use the get method, okay. All right. Now the next one is the head method. That means it requests the headers only that would be returned if specified URL were requested with an HTTP get method. That means it is just going to receive the headers. Okay, so that is the HTTP head method. Now, in the put method, what you do is that suppose you have some file to upload. Okay, so that for that application, you would require the put method. Okay, so you use the put method in order to upload some new file or a new object to the server. And what it does, it completely replaces the file that exists at the specified URL with the content of the body of your post method. Okay, so see here in the put method, see here the put will change. Okay, your HTTP URL, sorry, the URL, your HTTP version, and the information about your header field name. And this entity body, in case of your put method, will consist of the object that you want to send to the server. Once it reaches the server, at that point, it will replace what is there at the server side. All right. So now you have already sent a request via, sending the HTTP request message using several HTTP commands. Okay. So now you are basically expecting a response from the server side. Okay. So how do we receive a response from the server side? A response from the server side looks something like this. That is, we are using HTTP 1.1, so it looks something like HTTP/1.1, a number that is 200 is an example here, and then OK. All right. So what is it? This basically says, this is basically a status phrase, okay, consisting of a status code which is given by this 200. Okay. So we'll elaborate on this a little bit. But first, let us look at how the response message looks like. Okay. So similar to the header part of the request message, the first one will be the status line. In the request message, the first one was the wait. In the request part, the first one was the request line, then the header lines, then the body. Whereas in the response one, first line would be the status line, that is what status you are receiving from the server side. Then the header lines that will of course have the information related to what is the related to the information that you have received from the server side, and then you have the body. Okay, the body will consist of the data that is being sent from the server side. Okay, so see, what is the header line consisting of? It is consisting of the date, okay, the server version, okay, Apache version here in case of this particular scenario. What was the last modified date of the data that you have requested for? An entity tag, we will read about entity tags in the next class, accepts ranges in bytes, What is the length of the content? 2651 bytes, and the content type is text or HTML with cache set as UTF-8, and that's it. With carriage return and line fit, you finish this. Alright, and then you have the data in the body. Alright, so this is how an HTTP response message would look like. Now, we saw that the response message consists of a status line, and the status line consists of status code. Okay, so here are some status codes. So what does the status code give out? The status code gives the information of the request that you had sent and the response that you have got from the server. So for example, if you had requested to open a particular page and your request has succeeded, that means your server side was successful in sending you the requested object. Okay, so then you will receive this status code 200, and the status in the status line you will also receive 200 OK, right? So that means what, your request has succeeded and the requested object is there in this message in its body later in this message. Okay. Now, if you receive a status code of 301, then that means the data has been moved permanently. The data that you have requested for, that has moved permanently. Okay, but the location in which it has been moved, that means the new location of that requested data is then given in the body of that response message. Okay. Now, similarly, you have 400, which is basically bad request. That means the format in which you have sent the request to the server was unable to understand that. Okay, and this is the next one is, I think all of you know this and all of you have come across in your day-to-day life. That is 404 not found, server not found. Okay, so that means the document that you have requested to the server, that is not available with the server. Okay, it is not found in the server at all. So in this scenario, you consider 404 not found, and 505 is that if there is a mismatch in the HTTP versions with the server and the client, then you get this response, that is 505 HTTP version not supported. Okay. So these are some of the example status codes that you can get as response messages. Okay. Moving on. So when we were studying about HTTP, we had seen that HTTP is basically a stateless protocol, right? So that means it is not going to keep the information of the requests or that have been made to the server. Okay, so that is why it is known as a stateless protocol. Okay, so suppose I want to have a stateful protocol. Okay, so that means what can I do in that case? Okay. So first is you send request for this data X, which is at the server side. Okay. So what you do, your client side asks that log data record X, and the server side says, okay, fine, I will log this for you. All right. Now, if there is an update that needs to be made, then the client side sends this request that, okay, please update X dash, and please update X to X dash. Okay. Now the server receives this information, makes the changes and says okay. Okay. Now again you want to change it and you want to say that, okay, fine, update X to X double dash. And then the uh, data at the server side has been changed. Okay. So that is X double dash. Alright. So now happens? You want to say that, okay, fine, now you unlock X. Okay, that means until this time, this client was using this information. After it's done, it says, okay, unlock X, and the server abides by the same thing. Now, what if there is a issue with the network connection or the client side crashes? Okay, that means you have made a change in a particular data at the server side. You have logged it for the particular client, and now because you have not received any unlock message, then what will happen in that case? Then there will be inconsistency in the data that is there at the server side, right? So it can create some issues. All right. So you want to have statefulness, but statefulness may create certain issues. All right. So our objective will be to have a scenario where I can still have a stateful protocol, but I would like to avoid the problems that comes with it. Okay. So can we do it? So this can be done with the help of cookies. Okay. So I am very sure that all of you are um, very much aware of what cookies are. You know what are cookies. You have seen this in your day-to-day life. But what is cookie exactly, and what does it work for? Okay. Why do we need the cookie? So cookies are required to maintain state between transactions. Okay. So how do we achieve this? By having four components. One is that first cookie header line of HTTP response message. Then we insert a cookie header line in next HTTP request message. Then what do we do? The cookie file is kept on the user's host, which is managed by user's browser, and then the same thing is updated at the backend website, backend database of the website, at the website. Okay. So this might seem very confusing. So let me just explain you something. When you go back to your home, I don't know, some of you may have checked this, some of you may not have. You will see that your system has a folder called cookies where you have folders which represent different websites for which you have accepted cookies. Okay, so those have information related to your browsing history for that particular website. Okay, so cookies basically enable that information. All right. So for example, you are going to Amazon website or Flipkart or some other website like this. So you will know that what was your previous history, what were you browsing. Okay, so that comes with this cookie. All right. So this is an example. So let me give this one. Yeah. So this is a better example. So suppose this is at the client side. Okay. So you identify it with a ID. Okay. For a particular website that you want to get an access to, you identify yourself with a ID. Okay. In the cookie file. All right. So what happens? You just send the HTTP request message from the client side. Okay. So what does the server do? For each client, the server will create a cookie ID. Okay. So that is this from the Amazon server. When you are accessing the Amazon server, what it does, it creates an ID for user, and this ID is updated at the backend database of that particular website. So for Amazon server at the backend database, for you as a user, this cookie ID has been created. All right, with just the request message that you have sent. All right. Then what will happen? The server will of course respond. Okay, with the HTTP message, a response message. Now with the response message, an additional information will be added or sent to you, that is set cookie to this ID. So in your system, you will have a cookie corresponding to your Amazon website with this ID. Alright, so this is done. Now, next time when you try to open the Amazon website and you use the same HTTP request method, request message, then this cookie will automatically be added with that request message. Okay. So once this is added and the server receives this kind of a request message with a particular this ID, so in that case, it will do the cookie specific action. That means when it gets the ID, it will send that information to the backend database, which will basically get all the information related to the particular user's access, and then it will do the action, cookie specific action. Okay, that means what was your history, what is in your shopping cart, what was the thing that you were looking for in your past browsing history, etc. And then this is sent, and then whatever you have asked for, that is basically given out as a response from the server side using the HTTP response message. Okay, now this will remain in your in your client side as well as the backend database, this information of your cookie ID, and whenever you go back, you will access the information with this ID itself. Alright. Okay, so I hope this part is clear. So, what can cookies be used for? Okay, so as I already mentioned, to find out, what was there in your shopping cart when you had last done some browsing for a particular maybe shopping website. Some recommendations for you by knowing what you were looking for, you get recommendations, right? So in order to give recommendations, the backend server needs to run some algorithms on the data that you actually send to them, right? So this is how they get that information. Okay. So for recommendations, also cookies are helpful, and of course for authorization of the user, the cookies will be useful. Okay. And yes, in case of web email, to keep the user session state, cookies will be helpful for that reason. Okay. Now, how do we keep the state using HTTP and cookies? So at protocol endpoints, what do? We maintain state at the sender or receiver over multiple transactions. And in messages, what we do? In messages, we use cookies which will help us to carry the state information. Okay, so if you remember the figure that I was showing you, that if you simply want it to be a stateful transaction, there can be issues if there is some kind of a loss of connection at the at the client side, perhaps. Okay. But that will not happen if you are using cookies, because both the sides of information of and they communicate with the help of the uh, cookies. Okay, the ID that has been already given out by the server side to the user. Okay. Now, something to think about is that cookies are basically giving a whole lot of it is showing the server side a whole lot of information about a particular client. Okay, so security becomes a concern when you are using cookies. Okay, so this needs to be a concern, and when you go on reading advanced versions of networks, then you will look at privacy, and how to reduce the amount of um, data that you are sending, even using cookies. Okay. Okay. So next topic. So next is web caches. All right. So what is a web cache and why do we need it? Okay. So first, let us see why or what is the objective of having a web cache. Hmm. So first is that see, cache, if you know, I mean, by now I think you all know what is a cache. That means if you don't want to use the origin server, or basically the origin place from where you are getting the information, you don't want to access it continuously, what do you do? In between, you place some kind of a cache or some kind of a buffer where you keep the most used information, so that you can basically get the requested object, most requested object frequently within less time without accessing the original server. Okay, so this reduces on the time, this reduces on the resource that you are using to access the actual server, right? So that concept has been used here in web caches. Okay, so all right. So here we have, so this is the basic architecture that will be there. So you have the client side, there are several clients, okay, and this is the origin server. In between there will be a web cache, okay. So what would be the task from the client side? So at the client side, the user will configure his or her browser to point to a web cache. Okay, so first it will check if the data is in the web cache. Otherwise, it will send the request to the original server. All right. So what will happen? The browser will send all the HTTP requests that it makes to the web cache. Okay. Now, if the object remains in the web cache, it will send directly to the client side. Okay. If it does not remain in the web cache, then the request is sent from the web cache to the origin server, and then we receive a response. Okay. So this is how it works. Alright. So if it is there in the web cache, great, it will get. If it does not, then it will get it from the origin server, and it can keep it in the web cache depending upon how several factors. Okay, there are several cache replacement policies, there are several factors with which you will keep the data in the web cache. Okay, now web caches are also known as proxy servers. So I am pretty sure you have heard this term of proxy servers. So in our institute also we have a proxy server. So that means we have a web cache which acts both as a client as well as a server. Okay. So for your system it is acting as a server because it is giving you the requested object that or your browser has requested. It is not going, the request is not going to the origin server, but because the data was there in the web cache, it is being transferred to your browser. Okay, so in that way the web cache is acting as a server for your system, and if the data is not there in the web cache, then it sends a request to the origin server to give that information. At that point of time, the web cache acts as a client, and of course the original server will act as the server. Okay, so yeah, so the server will tell the cache about the objects that are allowed for caching in the response header. Okay, so that means you can see here, you can have this cache control information in the header. So either you can say that okay, these many seconds it can be there, or do not cache it at all. All right. Now, why do we need web caching? So, as I already mentioned, that it will reduce the response time for a client request, and if the cache is closer to, so this is supported because the cache becomes closer to the client. Okay, we know that for any data transmission, the closer the server is to the client side, it will also impact the response time in a positive way. Okay. So this is one, and next is that it will also reduce the amount of traffic that will be there to the server side. So here you see reduces this line reduce traffic on an institution's access link. Okay, so what we know about an institutional network, we had studied in the first class, first or second class, that about what is an institutional network. Okay, so what is happening in an institutional network? So you have your web cache, your proxy server, and you have your institute's router that acts as the uh, gateway to the internet. Okay, so that is basically your access link, the link from your institute's router to the ISP, which is providing the information, or the router of the edge router of the ISP, which is providing the internet connection to your institution. So, more the number of requests that go through this access link to the router at the ISP, to the local ISP. So, the link will be more and more congested. Okay. So, in order to reduce the traffic at that link, web caches or proxy servers are generally used. Okay. So, it reduces this traffic to a large extent, increasing, thereby increasing the throughput, overall throughput that is received by the users. Okay. Okay. So this is what I was talking about. All right. Okay. So conditional get. Okay, it's already 3:55. So we will talk about conditional get and all in the next class. So I think in the next class we have a holiday. It's a Thursday. So I think next Thursday we have a holiday. The next class would be on Friday in that case.